This is section 15.13 on what's called DEPT, or distortionless enhancement by polarization transfer, carbon-13 in NMR spectroscopy. Before we talked about, before being 1511, 1512, how you can't really get any structural information from a carbon NMR because we take out all of the couplings between carbon and hydrogen. So we don't know what the neighbors are really for each signal. However, that wasn't entirely true, as there are some very fancy techniques that have come to the forefront of chemistry in the past few years that have allowed us to kind of puzzle out or use logic skills to figure out what the connectivity is between certain carbons and the number of hydrogens. So this technique is called distortionless enhancement by polarization transfer, and it's a very sophisticated technique that relies on using two radio frequency transmitters during the procurement of the spectrum, and essentially allows us to selectively pick certain types of carbons over others. It's very complicated because it has to do with the pulse sequence that you use to find the resonances. So we won't go into that. But what you need to know is that we can use logic to determine the types of carbon we have. So in table 15.4, they show you the different signal patterns that you can expect for DEPT-13 carbon spectroscopy. And what's important here is this. If you have a normal broadband decoupled carbon NMR, every signal is present, meaning that any carbon, whether it's an sp3, 2, sp, or a fully substituted carbon with no hydrogens, all of those give signals that have positive intensity. However, if you run a DEPT-90 experiment, only the CH stretches, or the CH resonances, meaning only carbons that have exactly one bond to a hydrogen, show up as a positive resonance. All the other resonances disappear. So in this way, you can find which carbons in your molecule have a CH resonance. From the DEPT-135 experiment, you can find out which carbons have CH3s and CH2s, because CH3s, those groups will show up as a positive peak in DEPT-135, and CH2 will show up as a negative peak in DEPT-135. CHs are still a positive peak, but you don't have any just carbon signals, that is, carbons without any hydrogens. So through either the positive or negative characteristics in a 135, a DEPT-135 experiment, or the presence of a peak in DEPT-90, you can get an idea for the types of carbons that are present in a molecule. And this was section 15.13.